Hello everyone, and welcome to another video. In this video we're going to talk about two very important shapes when it comes to drawing things on screen, and that is the rectangle and ellipse shapes. Essentially, with the ability to draw rectangles, we can make squares, we can make rectangles of any height or width that we like, and then we can make squares by making sure the heights and widths are the same. And in a similar fashion, with the ellipse command, we can draw basically all kinds of ovals, horizontally stretched or vertically stretched, and circles of any size that we want by making sure that the diameters in both directions, vertically and horizontally, are the same. And we can see, we'll see in a moment, that the rules for colors are essentially the same as when it comes to lines, when it comes to that stroke command, what color line is around the edge. But we'll also see a new command for filling in the inside of the shape, because lines were not closed shapes, so they only had one color they could have. But closed shapes have actually two, one being the outline and one being the inside of that shape. So we'll see that in a moment. To start off, I'm going to go ahead and make my canvas a little bit bigger. I'll do 600 by 600. I won't change the background color, so if I run it, we can see it's and again, we have to remember that when it comes to colors, setting up colors, when you pick a color, if you're going to have multiple things, so for example, multiple lines or now multiple shapes, that stroke command and the one we're going to see in a moment affect everything after it. So if we want them to all be individual colors, then we have to make sure to remember to call stroke or other commands before each of the actual actions of drawing. So whether it's the line command or the rectangle command or the ellipse command we're going to see, you have to always set up kind of what you want it to look like before you actually do the drawing. Otherwise, you'll see that those colors will wrap around and then everything will have the same color, and that might be a little confusing. So let's go ahead and set this up. The default coloring for closed shapes is to have a white background and a thin black outline. So I'm going to go ahead and draw a rectangle once just to see it. And then we'll notice what that looks like by default, and then we'll be able to change its color. So I'm going to go ahead and put a note here, though. We'll say rectangle are given a width, a height, and actually before that, I should maybe correct myself, are given a position. And one of the rules is that the position that we specify is not the center of the rectangle, but actually the top left. And it's basically like you can imagine, if you know where the top left is, and you know how wide the rectangle is, you could draw a line across the screen to the however long you need it to be, and that's one part, or actually that's two lines out of the four of the rectangle, right? The top and bottom line. And if you know where the top left position in terms of up and down or vertical positioning is, that y coordinate, and then you know the height, then you could draw two vertical lines, and the result would be the four lines that you need. So we're given I'll say an x and y coordinate representing the top left of the rectangle and a width and height value, right? So let's try this out. The command is not the full word rectangle, it's actually a little bit easier. It's the word rect, and so there it is. You can see it turns blue in our editor. And so again, in that order, we must tell it, well, what is the x position? And if you don't remember, just kind of remember the top left of our screen is 0, 0. If we move into the right, we're going positive x value. So this is 600 by 600. The left side is the 0, the right side is 600, and anywhere in between is some number in the x coordinate. And in a similar fashion, unlike our typical mathematics, in this case, our 0, 0 for the y is 0's at the top, and down at the bottom is 600. So going down is a positive y value. If you put smaller values, you go actually closer to the top. So I'm going to put my rectangle somewhere, maybe on the top left here in this area. So maybe I'll do 75 to the right, so that's going to go a little bit this way. And then maybe 125 down, so that should go down some amount. So it should be somewhere around this area. And then now I'm at my width and height. If I want any rectangle, I can put any two numbers. If I want a square, we all know that squares are a subset of rectangles, meaning all squares are rectangles. But it's not necessarily true that all rectangles are squares. The distinction being squares have equal sides on all four sides. So the width and height must be the same to be considered a square. So let me go ahead and do that. I'm going to go ahead and put 100 by 100. So I'm saying this thing's at position 75, 125, x, y. And it is 100 pixels wide and 100 pixels tall, which is a square. And the result, don't forget our semicolon, is to run this and see that default. 75, 125 is this top left corner. So if we had to figure out where the center of the screen was and we tried to place it there, then we might have to do a little bit of math, and we'll do that in a minute. But really, it gives us a lot of control over how we place things, and as long as we are aware of the positioning, just like with lines, we can pretty much put any shape anywhere we want, including rectangles. Let's go ahead and change the size just to prove that this is longer. So if I put 200 for the width, the height, this should be twice as tall as it is long. So that means it should stretch downward. Let's go ahead and see that. And there it is, right? This is twice as long as it is tall. 100 pixels wide, 200 pixels tall, right? And so that's great. This is, I mean, that's as easy as it is. Just like line had four values as well, right? The x and y of the first point and the x and y of the second point. Here we have kind of, it's a little different interpretation. It's the x and y of the top left, and then how wide, and then how tall. Let's go ahead and do some coloring. Just like before, we can use stroke to pick the outline color, and we can use stroke weight to create the outline thickness, right? And again, once we start using them, pretty much if we're going to make any other shapes, we're going to have to use them all the time. So let's go ahead and do that. I'll say stroke, and I'm going to put a red outline. So 255, 0, and 0, right? Remember that the values for stroke are RGB. If we use three numbers, the redness, the greenness, the blueness. And we could always look up a color picker to decide if you want any other color, what's appropriate, and what numbers you would need to make that color happen. So I run this now. There. Stroke weight. And again, this number is one number, and this is how thick in pixels. So I think the default is 1 pixel wide, but we could probably put like, I don't know, 3. And then let's see what that looks like. And there it is thicker with that default color of the inside, which is white, and then our outline or stroke is red. So now that new command I want to tell you is the inside. So stroke is outlines or lines, and the inside of shapes is what we call the fill color. And in fact, you've probably seen this before. If you've ever used paint on a computer or any very simple kind of image creator, then the fill, which is usually like a little bucket of paint, represents like the filling inside of a shape. And that's exactly what we call this, the fill command. So I'll go ahead and put a note here. Fill chooses the inside shape color. So I'm going to go ahead and say fill. And the order, just like before, does not matter. I could have done stroke weight and then stroke and then fill, or I could have done fill and then stroke weight. The order of these does not matter because what happens is these are just kind of like setup. And then finally, when the drawing occurs, that's when all that information is used. So whether you put this one fast, it's so quick, the computer's so fast, that it's not really important which of these properties is set first, as long as they're set correctly before the drawing occurs, right? So I'm going to go ahead and pick a color. I'll pick in, I don't know, I'm going to put maybe a little bit of red, so like 30 red. I'll put 120 green, and maybe 100 blue. And let's see what that looks like. Color, right? And so there it is. And again, these three numbers, you could put anything you want. And it follows the same rules as background. It follows the same rules as stroke. If I put one number, then that would be a grayscale number between 0 and 255. Those are our ranges for all these color commands. And so same thing applies for all of these, right? So this is a pretty nice property. Very easy to manage. So that's pretty much it for rectangles. So again, I could place this anywhere. Let's do real quick, though. If I wanted to put it in the center of the screen, let's think about the math we'd have to do. If I wanted that top left in the center, that's not too hard. If this thing is 600 pixels wide, the halfway point would be half of 600, which is 300. So let's put 300 here. And then similarly, if we want it to be halfway down, then we would have our halfway point from top to bottom. If this thing is 600 tall, halfway is 300. So this would also be 300. And then let's go ahead and run this. Look like it, but this top left corner is right in the center. Now, unfortunately, that doesn't put the shape in the center because it kind of draws outward. So let's think about the math we could do to calculate where we need to be in order to adjust it a little bit. So if this thing is the center, I want the center point to be the center of my rectangle, then what is half of our width? Our width is 100. So if we shifted 50 to the left, then our center would be on the center of the screen. So 50 left of where it is half, or 50 less left of 300, so that is going to be 250, because if you go left, the numbers get smaller. So we're going to say 250. And there it is. And now for the y, again, if we want the center point of our rectangle to be at the center of here, it's kind of too low. If our thing is 200 tall and our corner is at 300, half of 200 is 100, so we have to go 100 up. So what is 300 minus that 100? It is 200. And there is our positioning. And we can see this, and let's see what happens. We'd have to change our numbers, and if we had more time, we could definitely talk about, well, could we generalize this for any shape and any size? And the answer is absolutely. We could do a little bit of math with what we call variables, and this is very much like math, where if we know just a variable that represents a number, we could just use that in a formula to calculate the position and have it change dynamically. But in this video, we're not going to go that far. We're simply just going to make sure we're comfortable with the little bit of mathematics we might have to do to position things and have a good sense of where they are, right? So now this is at 250, 200, but the result is that the overall shape is centered on the screen. Okay, so let's move on to our ellipses, and essentially The rules are almost the same. In terms of colors, stroke, fill, and stroke weight, exactly the same. There's no difference. So I'm going to go ahead and pick some colors for that. So I'll say stroke will be, let's try 0, 75, and 200. So a lot of blue. Actually, let's do maybe 150. That's it. We'll do a lot of blue and a lot of red, but not too much green. And so there's my stroke. We'll do the stroke weight. I will make it thinner, back to 1. And then now my fill, I'm going to go ahead and do, I don't know, let's say no red, no green, and then very little blue. So let's do like 75 blue. So it should be a dark blue. Now, for our rectangles, it was the top left was our x and y, and our width and height were the third and fourth parameters. For our ellipses, so the ellipse command, and again, if you don't know, just like all squares are rectangles, but not all rectangles are squares, we could argue that all circles are ellipses, but not all ellipses are circles. Essentially, because a circle is an ellipse where the width and height or diameter vertically and horizontally are equivalent, and if they're not, then it's more like an oval in some form. And so let's go ahead and say the ellipse values needed are x, y, and I'm just being shorthand here, and then width and height. And again, width and height, you can imagine if you put a box around this circle, that's what it would be doing, the width and height. Or you can also call them diameters, and it's the same thing. So maybe I should rewrite that, and we'll say horizontal diameter, just we're using the circular terms, and then the vertical diameter. And so let's go and do this. Now there is one other thing we have to be aware of, that x and y are no longer the top left because it's not a box, so there is no top left really, but they're actually the center point. So actually ellipses are often very easy to work with compared to rectangles because we always know that the x and y is the center point. So if we want to put it in the middle, it's actually going to be exactly where we think it's going to be, 300, 300, or something like that. So let's do that last comment. We'll say the x, y coordinate is the center of the ellipse. So that's important to note that those are two distinctions between, or one big distinction between rectangles and ellipses. So let's try this. Ellipse is our command, and here we go. And I'm going to put it, I want to put it right over the center as well. So I'm going to put 300, 300, so we can see what happens. And then I'm going to make this thing not very big. I'll do 75, 75. So it's going to be a circle. It's not going to be, and it's going to be ellipse, but it's going to be a circle because the two diameters are equivalent. And a dark blue inline. And notice it is centered correctly, and it looks great because the reality is this is easy to work with, knowing that our center point is the center XY. And notice something, it's on top, it's not hidden because it's on top of the rectangle. And this is just like if you were painting in real life. If you painted a rectangle and you waited a bit for it to dry and then you painted a circle, the fact is the circle has to be on top because it was done afterward, right? The order in which you draw things has a huge impact. And so I'm going to just kind of prove this point by moving all of this code temporarily. I'm just going to go ahead and move this and put it above the rectangle, and then we're going to see that this is kind of actually a problem because we drew it first and then we painted a giant rectangle over it afterwards. So the order in which you draw things is absolutely important. So I'll put it back to how it was because otherwise we can't really see our circle. And of course I could move it, and let me go ahead and do that. I'll go ahead and put it, I don't know, 500, so a lot lower. Or sorry, to the right. I put the first number, so it's to the right. There it is. And then now let's go ahead and mess with the actual width and height and prove that this is in fact can be an ellipse. So I'm going to go ahead and put 150, which is twice as much. So it's twice as wide as it is tall. And there it is. You can see it stretches horizontally. Now it's an oval, and I could, of course, expand this. Let's go even further. Let's do 300. And I just want to prove the point that if you draw something and your numbers, the calculation it has to do generates it off screen, it will be off screen. Now, so this is kind of like, I guess, a painting where if you hit the edge of the painting of the actual canvas, you can't paint anymore. You can't paint in the air. But you can also see it kind of like a window. You're looking into this window, and if it's outside of the window, it's there. You just can't see it. It's kind of blocked off, right? So whether we like it or not, it is drawn, and the computer does have to do the mathematics of it. We just don't see it, which is maybe a waste of resources. But there it is. And we can arbitrarily change this. So I'll put this back to 150, and I'll maybe put this one to 30. So this is a very short. And we can see that now it's a lot taller than it is wide, but not by much. And we can play with the numbers in any way we need to make these things. So you can imagine, and if I overlay another one, I could do all kinds of things. So now suddenly we can make a face with circles for eyes and a circle for a head and things like that. Because we have the ability to make these two shapes. And that's a pretty important ability. So we'll stop here, and in another video we'll talk about some other shapes that are useful to make for us.